So welcome to yet another session on permutation and combination. Last class, I talked about factorial being a very important tool because we'll be using it very frequently in our counting problems. Second thing we did was the principle of counting, the fundamental principle of counting, which was the addition principle and the multiplication principle. So those who were not there in the last class, I would request you after today's class, the first thing you should do is watch the two videos which was shared with you in the last class. Hello everyone, good evening. Good evening. So let me begin today with the most important and the word which is there in the name of the topic itself, permutations, right? So actually we are now going to start with permutations, right? Permutations, as I told you, is nothing but arrangements. Nothing but arrangements. Okay. Arrangements, my dear students, is a two-step procedure. Okay, so let me just change my ink color. So arrangements is a two-step procedure which is basically made up of selection and ordering. Okay, now let me explain why it is made up of these two steps, selection and ordering. So let us say you want to arrange 3 people out of 5 people on a chair or on 3 chairs, right? So when you want to arrange 3 people out of 5 people on a chair, you need to select those 3 people, right? And start ordering them, right? So many people ask me, sir, selection is a step which is making up arrangement. So why don't we study the chapter combinations, which is basically another word for selections, before we study this chapter of permutations? You'll understand in some time is that permutation is more closely linked to the fundamental principle of counting. I think I had discussed this with you in the last class also. That is why we study permutation first, even though selection makes up, or selection is one of the, you can say, step involved in arrangement. Okay. So when you select 3 people, that is your selection process. That is what we call as combination as well. And whatever you have selected, you can order them in order to achieve the arrangement of 3 people out of 5 people on those chairs. Okay, so to give you an example, another example would be like let's say forming a team of 11 players for a cricket match, because you don't only have to select those 11 players but also assign a batting order to that. So that is an example of an arrangement. Okay, now arrangement, we are going to talk about a very important term which is NPR. This is a symbol that we normally use for denoting the number of ways of arranging R objects from N distinct objects. Okay, here the word distinct is very important, and I would like to underline this also. So when you arrange R objects chosen from, or you can say R objects from N objects, where those N objects are distinct. Guys, distinct is very important here, because this symbol NPR should not be used. Again, I am repeating, NPR should not be used if your objects are having certain number of identical objects, or for that matter, all the objects are identical. Despite telling this repeatedly, many of you, I'm sure, while solving questions, you will end up using this particular formula, even if the objects are identical. Please do not do that. It's a very sincere request from my side. NPR, the word, the symbol, makes sense only when these objects are distinct. Okay, so choosing 3 people out of 5 people, that you can write 5P3, absolutely. Let's say out of 20 of you, I want to select a team of 11. So I want to make a cricket team of 11. So I can say 20P11, I can choose a cricket team with a batting order given to that. Okay. So NPR is just a symbol. The value of this particular expression, or the formula for this particular expression, is n factorial by n minus r factorial. Okay. Now, how do we come to this formula? Let us try to understand from a very simple scenario. Let us say there are n students, okay, and there are r chairs, okay, there are r chairs, and you want to arrange these n students on these r chairs. Okay, so this is your first chair, this is your first chair, this is your second chair, this is your third chair, and so on. Let's say this is your rth chair. Okay, let me write rth chair. Yeah. Okay, rth chair. So how would you arrange them on these r chairs? If you're able to solve this question, then basically you will be able to get this formula, right? Many of you who had studied this topic in school, please let me tell you, this formula doesn't come from the sky. It comes from your fundamental principle of counting itself. Okay, let us try to solve this. How many ways can you fill the first chair? I would like you to, answer me in how many ways can you fill the first chair? N ways, yes, because there are n students and you can pick any one of them to fill the first chair. So n options are there for you. So n ways to fill it up. Okay. How many ways can you fill the second chair? You will say n minus 1. How many ways to fill the third chair? N minus 2. Okay. And so on if you continue. How many ways to fill the rth chair? It would be n minus r minus 1. Okay. Please see the trend. The trend is, if it is first chair, you write n minus 0. Second chair, n minus 1. Third chair, n minus 2. So whatever is the chair number, one less than that you are subtracting from n, isn't it? So now, as per the fundamental principle of counting, in order to fill this entire chair, or so as to say, in order to arrange these r people, okay, on those r chairs which have been chosen from n, you can multiply them. That means by fundamental principle of multiplication, it will be multiplied. I'm just opening the bracket and writing it as n minus r plus 1. Now, the formula here doesn't look like the formula that we have got over here, but trust me, they are the same things. So let me show how. Let me simplify this. So ideally, the fundamental principle says, or your basic concept says, this should be your expression for NPR. But normally this looks too ugly, right? Because you're writing so many terms, dot, 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 and all. So it is not that portable kind of a formula which you can, copy somewhere. So what we do is we simplify it even further. So what do we say? Let us say, had this trend continued, it is not continuing by the way, then the next term would have been n minus r, right? So multiply and divide with n minus r. In short, I'm not changing my expression. The expression is still the one which is written in white, right? So I'm just, in order to simplify it, I'm doing these kind of activities. So I multiplied with n minus r, divided with n minus r. Let's even continue further. N minus r minus 1, divide also by n minus r minus 1. Okay. Next will be n minus r minus 2, divide also with n minus r minus 2. Keep on doing this till ultimately you reach a 1. Correct? So, and similarly in the denominator, keep on doing it ultimately so that you reach a 1. Now, if you watch out the numerator expression, it would remind you of the product from n all the way down to 1, which is nothing but n factorial. And if you see the denominator term, it would remind you nothing but the product from n minus r all the way till 1, which is n minus r factorial. Okay, so this formula of NPR, which you have been using in school, this is the actual derivation for this. So it comes from your fundamental principle of counting. It doesn't appear from the sky. Okay, many of you are using this formula without knowing how it came. So many students ask me, sir, do I have to use this formula? Can I not stick to my fundamental principle of counting and solve all my questions? I would really appreciate if you can do that. I mean, I really wish you can do that. Okay. If you solve questions by your very basic counting principles, I'm sure the chances of making mistakes will drastically reduce. Okay, so please make a note of this. I'll give you some examples. Let's say if you want to calculate, what can I say? Let's say 6p2. Okay, what is 6p2? As per the formula, let us calculate that. Just a quick formula check we'll do. So 6 factorial by 6 minus 2 factorial. 6 minus 2 factorial is actually 4 factorial. Okay, so that will give you 6 into 5 into 4 factorial by 4 factorial. That's actually 6 into 5. Okay, 6 into 5, which is 30. Okay. Now, if you do this question from fundamental principle of counting, it is like there are 6 students and you want to arrange 2 of them on this chair, on these 2 chairs, right? So how many ways can you fill the first chair? So first chair can be filled in 5 ways. Second chair can be filled in 5 ways. First chair can be filled in 6 ways. Second chair can be filled in 5 ways. So multiplication principle says you need to multiply it because your job is made up of 2 subtasks, and till you do both the tasks, your task will not be completed. Hence multiplication. And you can see this gives you the same answer, 30. Right? So this formula that you are using is nothing but it's just a modification of your basic idea of counting, or fundamental principle of counting. Okay. Have you all noted this down? Let me take the attendance. I hope everybody is there in the call. Let's take the attendance. All right. So now let us look into a small question based on this formula. Find R if 22p r plus 1 is to 20p r plus 2 is 11 is to 52. Find R. Yes, now very good thing that you pointed out, Madhav. Let me go back to the previous slide. Yes, please note when you're trying to write this, your n should always be greater than equal to r. You cannot say, let's say something like 2p3. It will not make sense, right? You cannot arrange 3 people taken from 2 people. It is absurd. It is not possible. Okay, NPR makes sense, even though I thought it was not necessary to say that when n is greater than equal to r. Equal to is fine, cannot be lesser than r. Okay, so in normal cases, n is always greater than or equal to r. All right, so come back to this question. Find r if 22pr plus 1 is 20pr plus 2 is 11 is to 52. The count has increased of the number of students. Anybody who has just now joined in, kindly let me your name, else it'll go as an absent in your class pro, because I have just taken attendance. You can just privately message me that I joined. Anybody who just joined 5 seconds back. Yeah, so 10p10, Madhav. 10p10 would be the answer. That means in that case you'll say 10p6 because you're trying to select and arrange 6c. Arranging people is like finding the proper selection out of those 10 chairs. Are you getting my point? So selecting and arranging the chairs among themselves is itself like making people sit on them and arranging the people. So even if you have 10 chairs and only 6 people and you want to know how many ways can you make people sit on that, it will be still 10p6 only. Got it? Anybody who joined the call just few minutes back? Because when I took the attendance, the count was 28. Now it is 29. Okay, fine. I'll keep in mind. Done. Okay, guys, I'll be slightly faster today. We have to cover a lot of ground. So anybody with the answer? Sorry. Anybody with the answer? Okay, so 22 PR plus 1 by 20 PR plus 2 is 11 by 52. Okay, so 22 PR plus 1 is 22 factorial. By 22 minus R plus 1 is 21 minus R factorial, right? Denominator would be 20 factorial divided by 20 minus R plus 2, which is 18 minus R factorial. Okay, this is 11 by 52. First of all, what I can do is I can express a higher factorial in terms of lower factorial. For example, this 22 factorial, I can write it as 22 into 21 into 20 factorial. And this 18 minus R, let it be as it is. 21 factorial, I can write it as 21 minus R, 20 minus R, 19 minus R into 18 minus R factorial. Okay. What is the benefit of doing that? The benefit of doing that is the factorial terms, you can easily lay them off. Okay. All right. So I think 11 also will go here by a factor of 2. Okay. Now let us try to simplify. So all the denominator terms I am taking to the right side. Okay. And this I am taking on the other side, 2 into 21 into 52. Now solving this equation by expanding it is a suicidal attempt. Yes, definitely a suicidal attempt because you're wasting a lot of time there, right? So here instead, try to apply your mind. See the left-hand side terms. Left-hand side terms are whole numbers that are consecutive. See 21 minus R, 20 minus R, 19 minus R. They have to be whole numbers for sure, right? And they're consecutive. So why don't we make an attempt to write the right-hand side as a product of 3 consecutive whole numbers. So let's see how we can do that. I can write 21 as 3 into 7. I can write this as 14 into 3, right? Or 13 into 4. Sorry, 13 into 4. My bad, 13 into 4. Okay. Now you can check. You have 12, you have 13, and you have 14. So basically, it is nothing but 14 into 13 into 12. Okay. Now, when you're trying to solve for R, just compare the corresponding term with the corresponding term on the right side. For example, you can compare the smallest one with the smallest one. So 19 minus R is 12. That means R has to be 7. Okay. Please kindly do not waste time making a cubic equation and solving for it. Many times you may end up getting a 5th degree equation also. It's not possible to solve it in the examination condition. It will take at least 10 minutes, 15 minutes to do that. Okay, so this is a smarter way to solve this question. Is this fine? Any question, any concerns, do let me know. Now somebody else has joined in. Now who has joined in right now? Please personally ping me. Somebody has joined the call now. Because attendance has been taken. So if you are joining in now and you're not letting me know, you may be marked absent. Okay. Let us now look into properties of NPR. Properties of NPR. The first thing that we need to remember, as well as keep in mind, that NP0 is 1, but NPN is equal to n factorial. Okay. NP0 is 1. That is the number of ways in which you can arrange 0 people chosen from n people is 1. Right? Don't do anything. Automatically it is taken care of. NPN means you want to arrange n objects among themselves, or you want to order n distinct objects among themselves. That means you're doing shuffling between them. That's it. So that would be NPN n factorial. So remember when I was talking about factorial, this is what I was actually talking about. Factorial of n is nothing but the number of ways in which you can arrange n distinct objects among themselves. That means you can just order them. The number of ways to order them among themselves is NPN, which is n factorial itself. Okay, this is the very first property. Second property is NPN minus 1 is same as NPN. Now I will say very obvious, sir, because npn minus 1 is n factorial and n minus 1 is 1 factorial, and this guy is n factorial by 0 factorial, and both are same. That is fine. But I would like you to prove this by logic. Can you logically prove by the definition of NPR how NPN minus 1 is same as NPN? Just by definition. Anybody would like to unmute himself or herself and discuss with me? Okay, let me prove this logically. See, let's say there are n students, okay? And there are n chairs on which I want to arrange them, okay? And out of this n student, there is one guy, okay, who urgently has to go out, let's say Mr. A. Okay. He says, sir, I'll be back. I have a very important call to make. I need to inform something to my parents. I'm coming back. So I said, okay, go. Meanwhile, n minus 1 people I need to arrange on these n chairs. How many ways can I do it? You will say n, p, n minus 1. Correct. Now, this guy, after making an urgent call, comes back. Mr. A comes back. In how many ways can I arrange him? This guy who makes a call and comes back, how many ways I can arrange it? Exactly, Anurag. One way. This fellow has to occupy the vacant seat left, isn't it? Are you getting our point? So whatever arrangements you're making, that one seat which is left off, he has to come and sit there. There is no other option because he was not there when I was arranging the remaining n minus 1 people, right? So eventually, the act of arranging n people on these n chairs, what I did, I broke up into two events. Of course, the two events must be done. Both of them must be done in order to consider the work to be done. So one sub event was arranging n minus 1 people, and the second event was arranging the last person who comes, after making the call. So why into many people will ask me? Because without having done both the work, my entire job will not be considered to be complete. Right? Easy, is it? So why I'm telling you all these things? Will JEE ask you all these things? Will school ask you all these things? No. But why am I doing this exercise is because it will open up your counting faculty, your ability to count, your ability to solve questions, right? That is much dependent on these type of approaches. We'll do a lot of questions today where you'll realize that formula etc are useless if you are not able to break your events like this and try to break the problem to a simpler chunk and solve it. Okay, next one, I would like you to note down very important property. NPR is n times n minus 1 PR minus 1, right? Now I know each one of you can prove this by the use of your formulae, but I want you to give me a logical proof for this. Can anybody give me a logical proof for this? Logical, just by logic you proved it. NPR is n times n minus 1 PR minus 1. You can speak out if you don't want to write. Sir, too long story. Can I just dictate it to you? Pranav, please complete it. So one student leaves, so what happens? Let him leave. What is your problem statement here? Pranav, let me be more specific. Left side says the number of ways to arrange R people, number of ways to arrange R people out of N people is NPR. How is this same as the right hand side term? That is what I want to know. Okay, Harian, sounds good. Okay, many of you are coming with your own story. Very good. Most of you are giving me very right explanation. See, I'll just make it very simple for you. Let's say there are n students. Okay, there are n students, and there are R seats or R chairs, you can say, in front of them. And I want to arrange these, and I want to arrange R students from these n students on these chairs. Okay. Now see how I'm trying to do this activity. There is one chair, let's say the very first chair, which is a special chair. Okay. This chair is a special chair. Okay. So when I'm trying to arrange, I would like to first, find a suitable candidate for the first chair. Okay. So how many ways can I fill up this special chair? Those are chairs. One chair is very special, right? You can say it is a hot seat, right? And I want to fill up that hot seat first. How many ways can I fill that hot seat? You'll say n ways. Yes, absolutely. Correct. Because that chair can be filled up by any one of these students, right? Now, how many chairs remain for me? How many chairs remain for me? R minus 1 chairs remain for me. How many students remain in the crowd now? You'll say n minus 1 students remain in the crowd because one is already sitting on this special chair. Are you getting my point? Yeah. So the remaining r minus 1 seats, you can arrange r minus 1 people from n minus 1 people in these many ways. And this is basically the same work as arranging r people on these r chairs from those n people. Is that clear? Right? I just made up a story. You can have your own story. You can have your own story. Okay. So what logically proves it? That is acceptable. So again, I broke the task into two parts. Part one was filling up the special chair, which was the first chair. And part two was filling up the rest of the chair. Is it fine? Yes or no? Is it clear? Okay. Now, I'll come back to another version of the same proof. Okay. Another shape of the same proof. Meanwhile, this property is extendable. That means you can write it as n minus 1 into n minus 2 pr minus 2, or n minus 1 n minus 2 into n minus 3 pr minus 3, and so on. Okay. Sorry, I'll just write it properly. Yeah. Now, basically, I'm using a recursive property. Since NPR itself is this, you can further break this guy by the same property. That means in order to get this, just replace your n with n minus 1. Replace your r with r minus 1. Okay? And you can continue doing it till you reach a 1. So till you reach the n minus r plus 1, okay, which is going to be your last term. So if I ask somebody, how would you prove the second one? Can you prove this one? Prove that NPR is n minus 1 into n minus 2 pr minus 2. How would you prove it? You say simple, same approach. Now instead of one hot seat, let's have two hot seats. Very good, Hariharan. Exactly, his thinking process matches with mine. So instead of one hot seat, two hot seats. So one hot seat can be filled in n way. Other hot seat can be filled in n minus 1 way. So remaining r minus 2 can be filled in n minus 2 pr minus 2 ways. And you can keep doing same things. Is it fine? All right. I'm moving on to the next page. So if you want to note down this property, please do so. All right. Next is fourth property. NPR by NPR minus 1 is n minus r plus 1. Okay. In other words, NPR is n minus r plus 1 times NPR minus 1. Can you prove this again logically? same hot seat mechanism will work. So I told you, so there's another way to look at the same thing. Can you prove this by logic? Yeah, anybody? Let's see if you have. Okay. Okay. Now see, very good. So here, the first thing that I would like you to do is fill this R minus 1 chairs. Correct. Now, if I ask you how many ways can you fill R minus 1 chair, there, especially when there are n students waiting to, chosen from. So you'll say NPR minus 1. Okay. So this is this term that you see. Now, at the last, you are filling your hot chair. Okay. So in the crowd, there will only be n minus r minus 1 people. So after you have chosen r minus 1 people, how many are left in the crowd? How many are left in the crowd? N minus r minus 1. Correct? Which is actually n minus r plus 1. Now you need one guy from that who can come and sit on this chair. And that can be done in n minus r plus 1 way. So here you are doing the same activity, but in a reverse direction. It doesn't matter, reverse direction, forward direction. Ultimately, I'm doing my entire work, right? Right. So entire work was arranging our people from those n people. So whether I fill the hot seat first and then the remaining r minus 1, or I fill the remaining r minus 1 first and then the hot seat, both are helping me to do the job. Yes or no? Yes or no? Okay. So this is going to give me this particular result. Is this fine? Glorified. Okay. So guys, let us take some questions based on this. I would like to take up some questions now. Let us start with this. First question is, if 8p5 plus 5 into 8p4 is 9pr, then find r. If 8p5 plus 5 into 8p4 is 9pr, find r. Right, Anurag. I just saw your reply. Very good. Absolutely correct, Aditya. Good. No, Pratik. Okay, if you are trying to solve this question by finding what is in 8p5 and 8p4, etc., please don't do that, because that would not be a very smart way to solve the question. Instead, what we can do is, let's take 8p4 common. Okay, if we take 8p4 common, you'll get 8p5 by 8p4 plus 5. Okay, and that is equal to 9PR. Okay, now just now we did a property, I think here itself. NPR by NPR minus 1 is N minus R plus 1. A similar situation basically is over here itself. Treat your 8 as N, treat your R as 5. So 8 NPR by NPR minus 1, isn't it? So won't it become N minus R plus 1? Correct? And this 5 we just copy over here. So this is 9PR. So this 5 goes for a toss. So it will be 9 times 8P4 is equal to 9PR. Now look at property number 3. I'll write it down. NPR can be written as N times N minus 1 PR minus 1. Correct? So what I'll do here is I'll write this 9PR as 9 times 8PR minus 1. Right? What does it mean? It means R is 5. Is this clear? See, that is called donkey's approach. Okay. See, you have learned your formula. What if it was an expression which led to very lengthy result? Will you still do it? Especially when you don't have calculators and all with you, right? So we have to apply our smarter strategy to solve these questions. Okay, so these properties are for a reason, right? And see, even if you solve it, then what will you do? Will you, let's say if you get an answer, will you start putting R as 1, 2, 3, 4, 5, 6, 7, 8, 9 and start checking which matches with your left hand answer? Will you do that? Even that would not be a good approach, right? So sometimes these properties are indispensable. Okay, next property. Prove that 1 into 1P1, 2 into 2P2, 3 into 3P3, and so on till n into nPn. This is equal to n plus 1 Pn plus 1 minus 1. Let me put brackets around these so that you're not confused. Yeah. Just type done on the chat box whenever you're done. If you would recall, this is very similar to one of the questions we did in factorial. In fact, it is the same question. I don't know how many of you recall that. See, 1P1 is 1 factorial. 2P2 is 2 factorial. 3P3 is 3 factorial. So ultimately, what am I asking you? I'm asking you to sum up this. Correct? Yes or no? In short, I'm asking you to prove that this is the expression, correct? In other words, I'm asking you to prove R factorial or R times R factorial from R equal to 1 till n is n plus 1 factorial minus 1. Now, do you recall this problem? How many of you do? Right, method of difference. Absolutely, Hariharan, you remember it correctly. Okay, again, I'll repeat it just as a customary thing. See, R into R factorial, you can write it as R plus 1 minus 1 into R factorial. This is nothing but R plus 1 times R factorial minus R factorial. Correct? So R into R factorial is R plus 1 factorial minus R factorial. This is what we call as the method of difference. So every term you can now break up as a difference of two terms. And this is not some ordinary difference. It is a difference which will lead to cancellation of many terms. Okay, so this is what we call as two consecutive functions in R. Same function, but one has a R plus 1, other has an R. So now start putting R as 1. So 1 into 1 factorial is what? 2 factorial minus 1 factorial. Put R as 2. So 2 into 2 factorial is nothing but 3 factorial minus 2 factorial. And keep on doing it. Let's say I reach R equal to n minus 1. It will be n minus 1 into n minus 1 factorial. That's nothing but n factorial minus n minus 1 factorial. Okay. And finally, when you put R as n, you get n into n factorial. And this will be nothing but n plus 1 factorial minus n factorial. So if you add them, the left hand side terms would be summation of R into R factorial from 1 to n. Right hand side terms would lead to cancellation of all these, lead to cancellation of all these terms. Okay. So ultimately this will also get cancelled. This will also get cancelled, leaving with n plus 1 factorial minus 1. That is what we wanted to prove. So while I was giving that problem, I told you, and I'll give you another version of the same problem. And this is the another version. Okay. So any questions, any concerns here? Do let me know. All right. Now time to take up some word problems. Time to take up some word problems. Let us start with this simple question. Okay, let's take this one. The number of permutations of n different objects taken are at a time in which two specified objects, they always occur together. Together means side by side. Okay. So two specified objects will always occur together. I hope the question is clear. So treat as if there are n people, and out of which you have to arrange r people. And these n people, you have to choose two friends, Ram and Sham, who, whenever you are arranging them, Ram and Sham will be sitting close to each, I mean, sitting next to each other. So how many ways can you do that? Okay, very good. Let's have one more minute. Please wrap this up. Last 20 seconds. All right, 5, 4, 3, 2, 1. Please vote, please vote. I can see 10 of you have not voted. Yeah, take a guess. Even if you are not able to solve it, you should also see how good a guesser you are. Okay, right. So most of you have said option B. Very good. See, take a situation where these n people that you have, or these n students that you have, or these n objects that you have, two of the objects are A and B, right? So first of all, these objects are always occurring, and they're always occurring together also. Correct? Yes or no? Right? Now, if you see the positions that these objects can occupy, where they are together, will be R minus 1 such positions, right? I'm just taking a small case. Let's say there are 4 places, then AB can come like this, or AB can come like this, or AB can come like this. Correct? Yes? So if there are 4 chairs, there are 3 ways in which AB can sit next to each other. Correct? So if you extend this to R chairs, right, then the number of ways in which A and B, the number of ways in which A and B can sit next to each other, will be R minus 1, but you have to also multiply with 2 factorial. Now, why 2 factorial is because for every such case, A and B can swap their positions. See, they want to be next to each other, right? They never say A has to be on the left and B has to be on the right, right? AB, BA can be a possibility. So here also AB, BA, AB, BA, AB, BA. So this 2 ways because A and B themselves can switch their positions in two ways or 2 factorial ways. Now remaining R minus 2 people have to be chosen from N minus 2 people and arranged. So the remaining people, the number of ways to arrange the remaining R minus 2 seats from N minus 2 people will be N minus 2 P R minus 2. So your task will be completed only when you multiply both of them. So total number of ways to do it will be R minus 1 times 2 into N minus 2 P R minus 2. I think yeah, they have actually expanded this. So let me do that also. This will be N minus 2 factorial by N minus R factorial. So I think it's option number B. B is absolutely correct. Janta was right. Well done, Janta. Next. This we have already done. Yeah, let's do this question. A tamer of wild animals has to bring one by one 5 lions and 4 tigers to the circus area. The number of ways this can be done if no 2 tigers immediately follow each other. If no 2 tigers immediately follow each other. I'll put the poll. Once done, you can reply me on the poll. Can you go back for a second? Okay. Anurag wants me to go back for a second. Ayyo Ramakrishna. Yes, Anurag. Any questions here? Do let me know once you're done. Go down and back. So this is down only. Yeah. Done. Okay. A tamer of 5 animals has to bring one by one 5 lions and 4 tigers to the circus area. The number of ways this can be done if no 2 tigers immediately follow each other. 2 lions can follow each other if they want, but not no 2 tigers, right? Because lions are very gentle animal. Tigers are not. Okay, so I've got 4 responses so far. 2 minutes gone. Let's have 1 more minute to do this. Okay, 5, 4, 3, 2, 1. Go, 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 go. Okay. Most of you have gone with option A. Okay. Let's check whether A was correct. See, this is what we call as gap theory, gap method. See, let us call these 5 lions be as L1, L2, L3, L4, L5. Okay. If you don't want any 2 tigers to follow each other, the way that they should be brought is where they could be placed in these cross marks gap. For example, let's say if a tiger comes over here, then the next tiger can come only in the places which are shown by the cross mark. So it can come here, 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 here. Okay. Now there are lesser tigers than lions. I understand that. So let's say if a tiger comes here, if second tiger comes here, third comes here, and fourth comes here. It doesn't mean that this place is left blank. There is nothing like that. Whichever place is blank, that will coalesce. For example, the order will be now tiger, lion, lion, tiger, lion, lion, tiger, lion, tiger. Okay, so this is one of the ways I'm just trying to tell you that. Okay, anyways. So now, let us take care first of the Hariharan. Yes, all the animals are unique here. They are like human beings. Okay. I mean, for you, they seem to be all same, but one tiger can, identify other tigers. Okay. Yeah. Anyways, that's a good question to ask. Yes, all the tigers and all the lions are distinct. So 5 lions, they can change these positions in 5 factorial ways, right? Right? All the lions can be intra-arranged in 5 factorial ways. Correct? Now, you have 4 tigers and they can come in these 6 gaps. So it is like you're choosing and arranging these lions in these 4 gaps out of 6 gaps. So it is like 6p4. That is clearly option number A. Janta was absolutely right. So it's 5 factorial times 6p4. Okay. Easy question. Any doubt? Any concerns? Yes. If neither tiger nor lion follows, then you cannot place a tiger in the first place and the last place. You can only place it like this. So that answer would then be 5 factorial times 4 factorial. Got it, Aditya? Okay. So if you don't want any two animals of the same species to follow each other, then the last two positions will not be available. Okay. Only lions can start and tigers can fill in the gap between them. You cannot start with a tiger. Okay. Next. Five boys and three girls are seated in a row of 8 seats. The number of ways in which they can be seated so that not all the girls sit side by side. Not all the girls sit by side by side. That means few of them can sit side by side. Yeah, I think they have calculated it. Don't worry. I mean, in most of the JEE questions, they would not give you a workload to calculate your results. Two minutes gone. 4 responses so far. Dear students, last 30 seconds. Please wrap this up in last 30 seconds. Five, four, three, two, one, go. Very confused response. Very confused response. A and C have got equal number of votes. Okay. Now let's check. See, can I say if I want not all girls to be seated together, can I solve this question by subtracting total case minus when the girls are seated together? Okay. Because I don't want to make cases like, okay, no girl is seated together, only two can sit together, like that. It'll take away all those scenarios into consideration. Correct. So total number of cases minus those cases where all the girls are seated together. That will give those cases where not all girls are seated together. That means two of them may be seated together or they may be all separate. Now, So what is the total number of ways in which they can be seated? You'll say 8 factorial, right? 8 people, 8 seats. You can arrange them in 8p8, 8 factorial. You can write 8p8 if you want. Now, if you want all your girls to be seated together, now see, this is what we call as a string method, right? So let's say there are 5 boys and 3 girls. So boy 1, boy 2, boy 3, boy 4, boy 5. And there are 3 girls. What I do is I take a string and I tie them together, right? Because I want them to move together wherever they can be placed, right? So tying them, or you can say, putting a string around them will keep them together, correct? So you can think as if you have now 1, 2, 3, 4, 5, 6 people, and you want to arrange them. How many ways can you arrange them? We'll say 6 factorial way, correct? But let me tell you, this is not the end of the story, because there is an option for the girls to intra-arrange themselves. Let's say here I can see G1, G2, G3. What if it was like G2, G1, G3? What if it is like G3, G2, G1? So like that, there could be 6 ways in which these girls can intra-arrange themselves. So that will be 3 factorial again multiplied to it, right? So your answer will be 8 factorial minus 6 factorial, 3 factorial. In order to simplify this, you can take 6 factorial common, and you'll have 7 into 8 minus 6, which is 56 into 6, which is 50. 50 into 720. 50 into 720 is 36,000. Option number A is correct. However, most of you voted for A, but most of you also voted for C. Any questions, any concerns? Clear? Okay, let's take the next question. Glad to know that, Madhav. Yeah, because this chapter doesn't come with any kind of a prerequisite. Like, it's like you know it because of your skills of counting. Unlike in calculus and all those other topics where there's always a formula and a method running in your mind, you cannot challenge that formula or method. Here, there is no limit to what you can think of. No, just the pattern B, E, G cannot appear in any word. For example, let's say if there's a word like this, I'm just taking an example. A, C, B, E, G, D. Okay. Or let's say F. This word is not allowed because a beg pattern is formed over here. I mean, you can see the word beg in that word. Okay. So neither the word beg nor the word CAD can appear in the number of words that you are trying to formulate, or in the number of permutations you're trying to make up. BGE can come, my dear. BGE can come. CDA can come. DAC can come. But the CAD, it's like you're trying to scan through a string. You should not see consecutive CAD alphabets in that string. Probably you can write a Python code for this. Oh, really, Shashwat? Okay, okay, Aditya. Um, just check your working again, Aditya. That doesn't seem to be a right answer. Same goes with Pranav as well. Okay. Okay, Madhav. Okay, now let us try to see this. I'll be using a bit of sets over here. Okay, set theory. As I told you, set is a very, very important ingredient in chapters like PNC and permutations and probability. Now the time has come that we now realize that how sets can, feature in to solve such questions. 143, is it so less? I don't think so. Answer is in some 4000s. No, no, no. None of you are right so far. None of you are right so far. No, Aditya. No shares. Okay, let's try to solve it. Okay. Now, let us say A is the event that, or A is a set which contains all words where the beg pattern appears. You can say all words with beg pattern is a set of all words with beg pattern. Okay. B is a set of all words with CAD pattern. Okay, fine. Now, what are we looking for? We're looking for those words which doesn't have beg pattern and doesn't have CAD pattern, isn't it? So in the language of sets, can I say I'm looking for the cardinal number of A complement intersection B complement, isn't it? Now we all know De Morgan's law, A complement intersection B complement is A union B complement. And this is nothing but total number of elements, that is universal set. That means the total number of permutations that you can make from A, B, C, D, F, that is your universal set, minus the number of elements in A union B, right? And A union B, we all know our property. It's nothing but NA, NB minus NA intersection B, isn't it? Now let us try to fill in these gaps. What is NU? What is NA? What is NB? What is NA intersection B? Let us try to find them out. Okay. Once we get them, fill it in this formula and that will give you your answer. Okay. Now NU means total number of words or total number of permutations you can make with these 7 alphabets. You'll say 7 factorial undoubtedly or 7p7 undoubtedly. Isn't it? No problem with that. Okay. What will be NA? NA is basically, oh, so sorry. NA is basically those words where the beg pattern appears. Where the beg pattern appears. Correct. So what I'm going to do is I'm going to take a string and I'm going to tie the beg word. Correct. So other words are A, C, D, and F. Right. So why I tied them? Because I want the pattern to be intact. I want them to move like beg everywhere. Okay. So in all those combinations where you can make from these alphabets, beg will be coming in those words. So it is like 1, 2, 3, 4, 5 factorial ways you can do that. Okay. Now some people must be thinking, sir, 5 factorial into 3 factorial? Tell me, will I do into 3 factorial? Yes, no, maybe. No. Why? Because I don't want beg to shuffle. EBG is allowed, GBE is allowed, like that it is allowed. Only that beg thing is not allowed. So you are not allowed to shuffle the beg alphabets among themselves. Only beg is not allowed. Yeah, correct. Can I say, my dear students, in the same way, CAD can also be treated? 5 factorial. Okay, no need to write it. No need to spend your time on that. Okay. What is A intersection B? A intersection B where you want beg and cad both to appear. So let's say beg and cad, tie them with a string. Down, down. Okay. What is the only alphabet left? I think F. Okay. Now three alphabets are there. Think like that. How many ways can you shuffle them? You'll say 3 factorial. Right. So your answer is loud and clear. NU will be 7 factorial minus NA is 5 factorial, NB is 5 factorial. Let me remove my face from here. Minus NA intersection will be 3 factorial. If you open it up, it is 5040 minus 240 plus 6, which is 4806. Unfortunately, nobody could get this right. Afsos. Aditya got it later on. Okay, Aditya, good. Pranav also got it later on. Is the idea clear, everybody? Okay. So sets, the chapter that you had studied was not a waste chapter. Now you are realizing its importance when we are solving these type of questions. Okay. Cool. Let me just pick up one more before we move on to another concept. Genius, like you all are. Number of words that can be made with the letters of the word genius. If each word neither begins with G nor ends in S. And here goes your poll. How you got A intersection B again? A intersection B shares is where beg and cad both will appear. A intersection B, A and B. Beg and cad both will appear. So what I did, I took two strings, I tied up beg, I tied up cad. So F, beg, cad, they are like 3 alphabets. You can shuffle them. Right? What sir, you're dancing and all. So 3 factorial ways. That's how I got it. Good, good, good. 3 of you have responded. And I can see the answer being marked. Happy to see that. Normally the trend which I have seen is the right option leads in the beginning of the poll, right? Towards the end of the poll, some wrong option takes over. You know why? Because when people don't get it, of course, today I asked you to take a call and take a guess. So many people start guessing because they're not able to solve it. So there are more wrongs than rights. So sometimes there are more than the number of people who have voted for the right options. So that's how sometimes, yeah. This is simple. This is in fact a lighter version of the previous question. Can we finish this up in another 40 seconds? Sir, does it mean G will never begin whether or not S does? Yes. The word should never begin with G nor end in an S. It can begin with an S. It can end with a G. That is fine. But should never Begin with G nor end in S. Okay, 5, 4, 3, 2, 1, go. Please vote. Okay, there you go. So I can see 21 of you voting, and most of you have gone with, oh my cursor, what is wrong with it? Yeah, most of you have gone with option number D. D for Delhi Daredevils. Okay, let's check. Guys, I hope you are not wasting your time on IPL. Sir, I thought you would ask, hope you're watching IPL matches. I hope you're not watching IPL matches. Right? Please do not watch. 2 years, don't watch. Don't worry, this will continue for lifelong. Okay. Very good, Akash. Right? Good. Don't waste time on these. They are, earning money. You're just wasting your time. Sir, it's not about money, sir. Entertainment and all. There are so many ways to do entertainment. Just go and run around your premises and come back. That is a better entertainment for you. Okay, now see. First of all, let's say A be the word that begins with G. Okay, same approach. Begins with G. B is the number of words that ends with S. Ends in S. Okay. Now what are we looking for? A beta and B beta. Don't want A, don't want it to begin with G, and don't want to end with S. Correct? From the very same formula that we had used, Morgan's law, we can write it like this, which is NU minus NA union B, which is nothing but NU minus NANB minus NA intersection B. Correct? Now NU is the total number of words that can be made, which is 6 factorial. Okay. NA is the number of words that will begin with G. That is 5 factorial, because if you fix up the G position, the other 5 places can be filled in 5 factorial. Okay. Plus NB, number of words that end with S, that is 5 factorial. Minus, now number of words which begin with a G and end with an S. That means if you fix the S position and G position, you have only 4 factorial ways to make the other words. So the answer is simply this. Okay, which is clearly 720 minus 120, which is 240 plus 24. That I think makes up 380 plus 24 is 5, not, sorry, 480 plus 24, which is 5, not 4. That's option number D. Some of you would have made cases, I know. That is also fine. I mean, but when this is there to help us, why not use it? Okay. Any questions, any concerns, do let me know.